Alrighty, hello, my name is Alana and this is Team 2's Exercise 5. So in Exercise 5.1, we were asked what are some shortcomings of the hierarchical clustering and briefly explain the main ideas underlining how perch clusters work. So hierarchical clustering struggles to scale with large data, especially for extreme clustering problems when the amount of clusters is very, very high. Perch clustering works by taking each data point individually and routing it to the node it is most similar to, and this creates a new leaf out of it. This new leaf is dissimilar to its neighbor leaf. Perch will rotate the node until the neighboring leaves are similar. It accomplishes this by creating bounding boxes around each node of the tree. These boxes are used to judge which node this new data point is closest to. And if you can see right here, this is an example of a hierarchical clustering. And exercise 5.2 asked us to explain k-means clustering and the main ideas, and what are some of the shortcomings of k-means clustering. So k-means clustering works by determining the closeness of data points to a chosen number of cluster points along the line or plane. It then creates new cluster points using the mean between the points located within each cluster and reclassifies each point based on which cluster point is it nearest to. It continues to do this until the variance within each cluster is closest to even. K-means clustering is not without its own shortcomings. One large shortcoming is the inability to create a set of optimal clusters. It also requires a lot of computing power when using very large sets of data. Computer power that most of us don't have on our everyday laptop. And finally, it is required that the user specify how many clusters the data is to be split between, as opposed to the algorithm selecting an optimal number based on this data. And then exercise 5.3 asked us to do the exercise Moneyball, which is an analysis on the NBA 2018 data set through our SASVIA software. So here you can see I have my SASVIA open. I went up here to Applications, hit Explore and Visualize, and started with New Data, the NBA 2018 report. And so with that, I imported that into my SASVIA. Before I began, I went over to Data and clicked what I wanted to do with that report. I clicked Cluster, and from there, it's kind of dealer's choice what you want to do, how you want to transform the data. So I started with creating a crosstab up here, and so just kind of what I wanted to do is organize the data a little bit better, kind of see how it was going to change and transform from this very basic table. So I started with the 259 player names of our observations, and then with the measures I was interested in, I selected points, rebounds, blocks, assists, steals, and I believe that is all. So once I imported that in here, I started my cluster analysis here with those same platforms. So as we can see, I made that a little bit larger. But it's really interesting because you can kind of scroll over these and see the cluster IDs. And you can look at the cluster summary. So it came up with 5 clusters. My third one has the least amount of observations, so it will be the smallest cluster. But my second one, yes, it has 88. So that one's going to be the biggest cluster I have. And it lists the nearest clusters. So the cluster that is a close distance, and you can double click this and see how they kind of overlap. There's similarities where the plots or where the points are plotted. The cluster cell. So this is for rebounds. So you can do the same thing with steals. And for all of these, you'll be able to see that. And then this really neat cluster ID wave here. Within the cluster statistics, you can see the mean and standard deviations. So for rebounds in cluster 1, you can see that the mean rebounds for the season or per game is about 0.335. Same for assists in cluster 4, you can see the 2. And here you can see the parallel coordinates plot. Yep, so we're just going to save this. I'm just going to name it cluster NBA. And yep, that's all we have time for. Thank you so much.